Hi, I'm Michael Pfeiffer from Industrial Metallurgists. This is a second of two videos on steel hydrogen embrittlement. The first video discussed, in the first video I discussed the embrittlement mechanism, and in this video I'll discuss how to prevent hydrogen embrittlement from occurring in steels. So the first video is on the mechanism of hydrogen embrittlement. I suggest you watch that before watching this video. And again, with hydrogen embrittlement, we are concerned about the failure of steel components due to the exposure of hydrogen that results in the components becoming brittle, losing ductility, and cracking and fracturing at stresses that are less than the metal's yield strength. So there are three requirements for failure due to hydrogen embrittlement. The first is that there has to be a susceptible material. In the case of steels, these are steels that are high strength steels. So they've been heat treated to get high strength. High strength means around 1,000 megapascals or about 145 ksi tensile strength. Also, the material has to be exposed to an environment that contains hydrogen, where the metal can absorb hydrogen that can then go to the grain boundaries and degrade the grain boundaries. And the metal has to be exposed to a tensile stress during use. And that stress can be from an external loading, or it can sometimes even be residual stresses, can be large enough to cause cracking due to hydrogen embrittlement. So in the case of steels, that we have a susceptible material, if the steel is heat treated to be high strength. If it's exposed to certain environments that contain hydrogen, that can absorb the hydrogen, and if the loading involves tensile stresses, then the metal can start cracking due to the tensile stresses on the metal. Electroplating is a common source of hydrogen. Common coatings are used on steel include zinc, nickel, and chromium, just to name a few. And hydrogen forms at the surface of components during metal deposition by electroplating. So the metal can absorb the hydrogen atoms, and those atoms can then diffuse to the grain boundaries and cause problems. So we want to be able to prevent hydrogen embrittlement of an electroplated steel, and that involves one major step, and that is to bake the steel within a few hours after electroplating. During the baking, the hydrogen is able to diffuse throughout the steel, and it diffuses to hydrogen traps throughout the steel. Hydrogen traps are areas within the steel microstructure that can hold on to hydrogen atoms. This includes things like inclusions, impurities, dislocations, and also grain boundaries are also traps. But we prefer that the hydrogen does not diffuse to grain boundaries, or at least diffuses to other traps besides, in addition to grain boundaries, so that the hydrogen does not weaken the grain boundaries. There are a number of different specifications or standards that discuss the baking requirements when high-strength steels are electroplated. And these standards discuss when to do the baking, the temperatures to use, and for how long. So to prevent hydrogen embrittlement, we have a few different options. We perform a hydrogen bake after electroplating if we're going to put an electroplated coating on a high-strength steel. The other choice or way to prevent hydrogen embrittlement is to use just a totally different coating process. If that we can use a coating that is not deposited by electroplating, but still provides enough corrosion resistance for the application. Also, we can reduce the applied stress on the component so that we can use a lower strength component and not have to have a steel that is susceptible to hydrogen embrittlement because it is so strong. So lowering the strength of the steel is another way to prevent hydrogen embrittlement. Finally, in addition to electroplating, hydrogen embrittlement can also occur during use, and I discussed this in the previous video. This includes during corrosion, because hydrogen is produced during corrosion, or if there is hydrogen in the use environment, such as with steels that are exposed to hydrogen sulfide. If you'd like to learn more, there are lots of different ways to do that. First is to subscribe to our YouTube channel. We have lots of other videos that are available on our channel that discuss metallurgy and how to engineer metals for reducing costs, improving reliability, and improving performance. Also, we offer metallurgy courses. These courses are designed for design, manufacturing, and quality engineers, and individuals can sign up, and we also offer group discounts. And finally, if you have questions, feel free to email or to call. So thanks for watching, and good luck with your metals. Bye.